It looks like you need to keep a running list of scores and recalculate it each time. But the real trick is to treat each new round as a stack operation, letting you add, double, or remove the last score in constant time. You are given a list of operations that represent a baseball game scoring system. Each operation can be an integer, meaning you record that many points, a plus sign, meaning you record the sum of the previous two scores, a capital D, meaning you record double the previous score, or a capital C, meaning you invalidate the most recent score. After processing all operations, you return the sum of the valid scores. For example, with the sequence 5, 2, C, D, plus, you first record 5, then 2, cancel the 2, double the 5 to get 10, and finally add 5 and 10 to get 15, ending with scores 5, 10, 15, and a total of 30. A naive solution stores every valid score in a dynamic list. When you see a C, you remove the last element. For D, you append twice the last element. And for plus, you sum the last two elements and append the result. Each operation touches the list at most once, so the time cost is linear in the number of operations. Big O of n, the list itself, grows with each valid score, giving big O of n extra space. While this works, constantly accessing the end of a list and removing elements can be slightly less efficient than a dedicated stack structure. The key insight is to use a stack, because all operations only ever interact with the most recent scores. We start with an empty stack. For each operation, we check its type. If it's C, we pop the top value, discarding the last score. If it's D, we look at the top value, double it, and push that new score. If it's a plus, we need the sum of the last two scores, so we pop the top value temporarily, peek at the next value, then push the popped value back, followed by the sum of the two. Otherwise, the operation is a plain integer, so we parse it and push it onto the stack. After processing everything, we simply sum all values remaining in the stack to get the final answer. You'll recognize this pattern whenever a problem only ever refers to the most recent one or two elements. Think undo operations, rolling sums, or any scenario where you need to add, double, or cancel the last entry. The stack solution runs in linear time, big O of n, because each operation touches the stack a constant number of times. It also uses linear extra space, big O of n, to store the valid scores. If you found the stack trick useful, try the next video where we apply the same idea to a different challenge. Like, subscribe, and hit the bell so you never miss a new algorithm explained for real engineers.